a negative. So Kiara and Princess are correct. If I multiply a negative by a positive, I'm always going to get a negative. So negative 2 times positive 2 is negative 4. Now, do I have enough points to create to graph?
Yeah.
And Kiara, what do you think I'm going to get? My first equation, I noticed, was simply a straight line. Is my second equation also going to be a straight line?
No, it's gonna go the opposite way.
So I had one no, and I had one it goes the opposite way. So Kiara says it's pretty much the same line, but it has a negative slope. Maria, who said no? Okay, so it's the same line. Is it also going through 0, 0?
Yeah.
Yes, why do we know it goes through 0, 0? Because when x is 0, y is 0, and it's also going right through the origin, but this time with a negative slope. Okay, ladies, today we have a new aim, and our aim is how do I evaluate and graph exponential functions? And recall the word exponential comes from the word exponent or out of place. The last time we used exponential functions was way back in here in geometric sequences. Geometric sequences, we noticed we had something very funny. I had a variable in the exponent. Does everybody recall? So I'm going to go back and just show you the little example that we used when we were doing arithmetic versus geometric sequences. So first of all, looking at the screen right now, what kind of function do we see? Does it look like something we just did? Nicole, what do you think? Does that look like something we just did? Yes? Yes. Ashley, what do you think? Does this look like what we just plotted? It does. Do you recall what that kind of function is called? Because it looks like a linear because it looks like a line. So we know that when we were doing arithmetic functions, we were graphing lines. What happened when we all of a sudden had a variable up in our exponent? What did our function look like then? Somebody said the word parabola.
I thought you were like,
That's interesting.
That's the second power or something.
Right, so now all of a sudden my function no longer looks like a straight line anymore. What does it look like to you, Kara?
Like a half of a circle.
Like a half of a circle, but it is definitely not a line. We get the sense that it's no longer a line, it's now some kind of curved shape. And how do I know that it's well, how can I change my curve shape?
Oh, that's cool.
Yes, if I change the common ratio, I can change the curve shape. Isn't this interesting? Anytime I move my common ratio, I change the shape. Does anybody recall when I'm moving my first term, what happens?
It gets bigger.
The first term is actually the A value. It's going to change.
It gets bigger.
So as I change the terms on my geometric sequence, I'm actually changing the shape of my graph. Amanda, pass you please. Okay, so let's go back to working some problems. So anybody want to tell me, like, why was that a line? Why did we just graph a line? What made that a line? The ratio, fantastic. Genesis, was that you that said it was a ratio?
No.
Yes. Genesis, what do you mean the ratio? Did the ratio change? Did the slope change? No, it did not. So the answer was, it was a line because the slope was constant. It was rising at a constant rate. So what happened when we changed, if the variable became the exponent? What does that mean? The variable becomes the exponent.
Like, it's called x to the second power during that x squared.
Well, what we're saying is that y equals some constant, and the variable is up here in the exponent's place. So my output, or my domain, is equal to my constant plus times a raised to the power of the exponent, which is the variable. our graph. We already had a little preview. We knew what happened to the change. Iman, can you remind me what happened when we changed our exponent from being multiplied by the constant to putting my exponent up here? How did that change the shape of my graph? We just watched it. We watched it change from being a straight line to... Somebody want to help her out? We had a straight line. What happened?
And then they got curved because the constant was the constant and the ratio. It was a ratio. I was close.
So when I have an exponent as my variable, I go from having a straight line, which is a fixed slope line, to having a curved or an exponential growth line. This will open up a whole lot of new ideas for us. Instead of having a constant rate of change, we now have an exponential rate of change. Did our procedures change, though? Do you remember our procedures for graphing a line? Did those change? And that's why I had you line them up side by side.
Not really.
Not really. No? Everybody agree? Not really. I still had my equation. I still set up a data chart. I still had a 3-column. And I still checked my work with my calculator. So our procedures did not change. That's the really good news. So we're going to hold off on this question about slope and whether or not I can still measure slope. But just kind of keep that question in the back of your mind when we're going through this thing. So let's go through really quickly and see exactly what this means. An exponential function. Anybody want to read this for me? Maria, go ahead.
An exponential function is a function written in the form of y equals ab without x.
Okay, and there's like a disclaimer on the bottom where a is a non-zero constant. Why do you think it's important that a is not zero? What would happen in my formula here if a were equal to 0?
What do you have, like, a line?
Well, if a were equal to 0 and I multiplied 0 times b raised to the x power, what would happen? What happens when I multiply anything by 0?
It'll
What?
It'll be 0.
It becomes 0.
Multiply.
Thank you. Yes, multiply.
But now it's range, it'll become 0.
But hold on. We're going to get there. So if I multiplied this by 0, my whole equation would go away and I really wouldn't be able to do anything. So I have a little note here on the bottom. A cannot be 0 and B cannot be equal to 1. Wow, that's another funny thing. Why can't B be equal to 1, I wonder? What would happen if B were equal to 1? What is 1 raised to the 100th power? Julie? You don't know? What is 1 raised to a billionth power, a trillionth power, a negative power? What is that line? It's always going to be 1.
Oh.
Anything, 1 raised to whatever power. So therefore, I know that A can't be 0 and B can't be 1. X, however, my exponent, can really be almost anything. Can it be a negative number?
No.
Didn't we just learn about negative exponents? Just?
It could be a negative, but then you don't have to, like, put the 1 over.
Thank you. Maria remembers then that I can have a negative exponent. That just means that I am going to take my base and turn it into the denominator. So we're going to pause on that for a minute, but just make sure everybody has the idea of what an exponential function looks like and recalls that the last exponential function we did was on geometric sequences.
Miss White.
So let's try one all by ourselves, and you'll see that our procedure is exactly the same. Amanda, could you write things down? You did a beautiful job writing yesterday, so I know that you can write. Could you take a minute and make sure you write this down? So let's do this one together. Ladies, Kiara, could you read that equation for me?
Y equals 5x. Y equals 5 to the x to the power x.
Fantastic. That is the one thing I want you to see. When the x is up here, it's not 5 times x, because we already know what that function looks like. It's 5
5x.
5 function, and I'm told that I, one, have to evaluate, and two, have to graph, I'm going to put my function right here in the middle. Y equals 5 raised to the x power. Y is going here on the far right-hand side, x is going here on the far left-hand side. So I'm going to start with 0.
There's no shorter way to do that.
There's a shorter way, but right now we're learning this way. We're learning a step-by-step method so that you can graph anything and evaluate anything with given numbers. Because I like to learn this way. And then if you feel really comfortable taking along, then fine, you can use your shortcuts. But let's learn this way first so that we have it down. Yes, I know. Okay, so ladies, here's my equation, and my instructions are to evaluate. That's my first verb. My second verb is to graph. Right. So evaluating, I'm going to start with 0. That's always a good place to start. When x is 0, y equals 5 raised to the 0 power, and we just established that anything raised to the 0 power is 1. So my first data pair is x is 0, y is 1. So how about when x is equal to 1? I have y equals 5. Now x is raised to the first power. And what's any number raised to the first power? Dee Dee, what do you think? 5 raised to the first power, or we just established that 5 raised to the 0 power was 1. Any number just raised to itself is 5. Thank you. That's absolutely correct. So 1, when x is equal to 1, y is equal to 5. My next data pair is 1 and 5. Clear so far?
Yes.
Everybody thinks it's real easy, right? So far, we're just learning how to graph it.
And next one is going to be. I have a question. Is there be
Hang on. So just let's wait for Maria's question, and I'll let you check. Go ahead, Maria.
Is it when you have like an exponent on the top of the number, like it's supposed to be like 1 over 5? Oh,
Right
it's when you
now,
have a negative.
yes, I don't have any negative exponents yet. We could have tried a negative exponent. Ladies.
No.
Shh. So, Evelyn, you wanted to finish this up for me? What about when I have 2? What about when I have 2? Now I have y equals 5 raised to the second power.
So 8 is going to be 5 times 5.
Yes, it is. Or 25. So I have my third data pair.
You're evident?
Well, you didn't do it.
So Evelyn, finish this up. What's my third data pair?
Your third?
When x is 2, what is y? 25. So we kind of noticed something interesting about our chart. The x values are going up very slowly, but the y values are going way up. So if I were just thinking what this might look like, well, x is going up slowly, but y is increasing really rapidly. Does everyone see how I derived using a very simple
So
function?
the line's not going to be straight?
So no, the line is not going to be straight. In fact, we now have our curved line. Y is going up dramatically where x is not changing by a lot. So what I'd like you to do when you check your work is to graph the function. So ladies, get your calculators out and let's check our work by graphing our function. So if you notice up on my chart, you'll be able to see what I'm doing every time I go. So ladies, let's first go to your y equals button right here, which is where I am. Y equals, what was our function?
5.
5
Equals 5.
raised to the x power, so I look for my x, and now I'm going to hit graph. And this is exactly what we thought our graph was going to look like.